Thank you for the introduction, Michael. Jennifer, you can go on to the next slide, please. All right. So thank you, everyone. I'm going to be talking today about the NASA Europe Aerospace Academy. This is a project run by NASA Europe, the Minority University Research and Education Project, which really focuses on K-12 STEM outreach, as well as actually K-16. But the Aerospace Academy is a 3-year cyclical program that has worked specifically with high school students, with expanding other outreach to the families of those high school students. So trying to hit the K-8 and also the families to improve STEM literacy through other smaller STEM activities, STEM days, and things along that nature. And then I pulled this quote from the NASA Europe website. So the goals of NASA Europe is to enhance research, academic, and technological capabilities at MSIs. I know everyone here is aware that UCF is a minority serving institute by providing authentic student learning experiences related to NASA missions that contribute to a secure future STEM workforce. Next slide, Jennifer. So there are 4 main components with the NASA Europe Aerospace Academy. The first and probably most prominent are the experiential learning opportunities. Study after studies have shown that in getting involved in some form of hands-on research or STEM activities really improves a student's STEM identity and really contributes to their continued success in the field. So the program develops these smaller activities building towards a capstone to give them experience with some form of engineering research. Every year that project changes, but the overall layout is the same. They also really promote engaging different opportunities with STEM professionals and settings. So obviously we are on that track of dealing with academics, but also we have partners such as the U.S. Geological Survey, the Florida Space Grant Consortium, and different industries that really promote different outreach avenues as well. And then they also really drive, building those connections with the community groups to spread the awareness of these opportunities. And we have workshops throughout the year. So because we recruit 9th through 12th graders, we kind of give a cautionary tale to the underclassmen, whereas for the juniors and seniors, we really try to work with them on the scholarships as well as application information. The community that we service is the local Orange Seminole County area, as well as Marion County, up about an hour and a half north of Orlando. So that community is, I believe, all but one school is a Title I school, meaning that they receive federal funds because their majority of their students are low income. And even being around like an hour or so away, the first time I went there to pitch this program to parents and students there, the vast majority of them did not know that UCF existed. Now, that was before we joined the Big 12, so I'm hoping that helps spread the awareness of the program. But that's still something that's relatively close and a lot of untapped potential just because the awareness isn't there. And then we have family nights, and they really promote STEM engagement by having showcases for the students to show off their activities with the students. Next slide, Jennifer. So this is just a recap of the year 1. So all of these are based off of NASA Glenn's has their Office of STEM Engagement site. So these are projects that are adapted from that, where they have competitions nationwide. And then we get a slightly tuned project that's a bit more in-depth to work with the students. So year 1, we had about 50 students, 20 through 2 different sites, either a Saturday session or a Tuesday, Thursday evening session at UCF, and then another group at Orlando Science High School. And so this project was to learn about the how treads are designed for like a lunar mission. And so students kind of identified the landing site, identified what obstacles there might be on a roving path, and then designed 3D printed rover wheels, specifically airless wheels, to traverse the simulated terrain. Next slide. Year two, we grew to the current size that we are, around 120 high school students. So we brought them down to UCF to tour. I'll talk more about that later. And then this year, the project was on acoustic damping, so mitigating sound from jet engines. And so we worked with subject matter experts from NASA, Glenn, as to build an impedance tube, and taught them circuitry and different elements of the design, test, and reporting phases. And then the students eventually went to the Orlando Science Center, where they gave their presentations and were able to tour the Science Center. Next slide. So these activities are very kind of small scale ones that build to a larger project. So we worked with them on learning how to read circuitry diagrams, going over what each component is, because many of these students hadn't had physics yet. So even, just your general Ohm's law, they might not have come across. So, we started with different activities to build them towards being able to read a circuit diagram like the one shown here, and then had them build a power amplifier circuit for a speaker, as well as a microphone circuit for them to use in their impedance tube. Along the way, one of the important aspects that NASA wanted to promote is using integrated technology. So we had them do activities such as, getting a frequency generator on their phone, and then using another phone as a microphone to test as an oscilloscope to test the wave function. Different things like that, where, it's no longer, you won't have a calculator at all times. You now have one in your pocket, but that's building to what other tools you have in your pocket. So those types of integrated technologies we wanted to demonstrate to them, as well as bringing in some lab hardware, some lab grade oscilloscope spectrum analyzers, to show them how maybe the waveform looks clean on a $20 oscilloscope, but if you ramp this up to a lab scale, you can kind of see some distortions. Next slide. So this is really what the capstone looked like. The students were tasked with designing, testing that kind of black and blue plastic piece on the right. So that was a different kind of a cellular structure that they were able to take inspiration from, nature, and we taught them biomimetics, as well as some other students went into kind of a deep dive into material science to look at different, maybe thermal insulators work well as an insulator. Does that hold for acoustic insulators as well? So we had students ranging from kind of like coconut fiber to rock wool, and all sorts of materials and different 3D printed designs. Some that made essentially muzzle type designs. We just let them run wild with this, as well as long as they provided us a reasoning behind their assumptions that this would work. And we had a large variety of different experiments that they were able to test. Next slide. So again, we took them down to UCF and toured a few different facilities. And then over the course of the year, we had about 70 contact hours with them. And this is through 12 Saturday sessions, 6 hours each, as well as another group that was weekly on Tuesday evenings. And so we showed them how to build the impedance tube as one simple build. And then again, the electric circuits building towards that capstone. Next slide. And I really could not do this all without these undergraduate and graduate students. These are just some of them that we had over the course of the program. So when I was pitching this program to them, pretty much all of these students said, I wish I had that when I was in high school, and wanted to take part. Some were graduate students already in the lab that heard about the program and wanted to help out. Others we recruited specifically for this project. But this is really, I think, where the project shines. Having students that fairly recently went through the transition from high school to university and giving these students the feedback on the different pitfalls and things along that nature that they wish they either did sooner or didn't do. And so every session we kind of have breakout groups where these students will talk with the different teams and kind of get that gauge on any anxieties about applying for colleges or things along that nature. Next slide. And I do want to give a shout out to when we did bring the students, we had a few professors open up their labs to the tour. So I want to thank Helen, Jay, Marcel, Jim, and then Richard Jerzek from the physics department who allowed the students to tour the facility, as well as we had some guest lectures, Sudeshna and Antoine, giving talks about the different health effects or other avenues. One thing that we really wanted to push that NASA fully supported was, while this is the Aerospace Academy, we wanted students to just get involved in some form of, engineering or STEM field. So opening it up to a variety of different engineering disciplines. We had guest lectures that weren't affiliated with UCF come in as well for things like electrical, civil, and so on. Next slide. And so very briefly, I know I'm running out of time. I do want to also talk about the 13 to 16 level research opportunities. So this is the program that I run along with SUBIF that the Navy through JHDO through the Navy sponsor our work for undergraduates. Next slide. So our research mainly deals in fundamental sciences for advancing combustion, rocket science, renewables, and propulsion. So anything that burns, we study. And so we have the ability to bring in 8 undergraduate students through this program to help them in research. Next slide, please. And so some are working in hypersonic facility and propulsion engine development, mainly the modeling and diagnostics of them. And then some also are just building outright the facilities to better capture the phenomena. And then we have others that are working more on the chemical kinetic side. And I would like to shout out these students as they are some really great ones that we've recruited through the program. Next slide. So to give you an overview, you can go ahead and skip to the end of this slide, Jennifer, please. So essentially, we deal mainly with the how processes, how ignition occurs on a microsecond timescale, updating computer models, and then reducing those models to package to our industry partners. And that's for lowering emissions and improving energy performance. And we do that through multiple facilities that we have on and off campus, mainly shock tubes, detonation tubes, and so on. Next slide, please. And again, like to shout out the students. Henry actually is a former MIREP Aerospace Academy student that wanted to get involved with MIREP. And so we brought him in to help this year for the program and is now also doing research with us. Next slide. And so we had these students, along with actually some of the MIREP high school students, present at SciTech through these papers, as well as the papers for in advancing aerospace education, where the high school students kind of gave their aeroacoustics talks. So I believe I'm slightly over, but I believe that it is the last slide. So thank you for the opportunity.